Okay, now we're going to continue our review for the Unit 1 lecture exam by going over lesson number 3, Patterns of Nature, Minerals. So in your textbook, this is going to correspond to Chapter 3. So you should already know by now what an atom is, and so this is just a review that rocks are going to be composed of minerals, and then inside minerals are going to be the atoms. Properties of atoms. You're not going to need to know what the size of the atom is, but you should know that it's so small that you cannot see it with the type of microscope that you would use in biology. Okay, you should know the constituents of the atom, that it composed of a nucleus, which has in it protons and neutrons, and then it has electrons in orbit around it. You should also know that electrons are negative in charge, protons are positive in charge, neutrons are neutral, and you should notice that protons and the neutrons are much, much bigger than what electrons are. Also, something I'd like for you to know is that the electrons do not go around the atom like planets in precise orbits that you can predict. It's more like a cloud, that the electrons are in a cloud that surrounds the nucleus, and you're never quite sure where a particular electron is, but you can say that with 90% confidence it's located within a certain distance of the nucleus. Another thing about the atom is notice the mass of an atom is incredibly small, so that you cannot take an atom and put it on a scale and measure its mass. Okay, then you should know that the force of electricity is going to be what holds the atom together. So since the protons are positive and they're in the nucleus and the electrons are negative, opposites are attracted. So you don't need to know about the formula for the exam. All right, now you will be given a periodic table for the exam, and so you should be able to read it. So know what the numbers mean on the periodic table of elements. So you should know that the number that does not have a decimal point is called the atomic number, and that's going to be the number of protons in its nucleus. The atomic number determines the element. So every hydrogen has 1 proton. Every helium has 2 protons. So the atomic number is going to determine the identity of the element. The number that's on the bottom is called the atomic mass, and so it takes into account the number of protons and the number of neutrons in the nucleus. The electrons in a particular atom, sometimes the electrons are knocked off, or sometimes an atom has an extra electron, in which case we say it's been ionized. So that normally an atom is neutral, meaning that for every electron there's a proton that goes with it, but sometimes an atom has an electron or multiple electrons ripped off. Other times an atom has extra electrons added to it, and then we're going to call those things ions. So I would like for you to have an idea for where the electrons live inside the atom. And so this is, I call this the atomic hotel, and so you'll notice that there are floors to the atomic hotel. So those are going to be called energy shells. And so you have the first energy shell, and then on top of it's the second energy shell, and then the third energy shell. The higher up you go, the more energy those electrons have. Then each floor is divided up into rooms. And so those are going to be called the subshells. And in some textbooks, they refer to those as being the orbitals. And so on the first floor, you notice it only has one room. And that room can only hold 2 electrons. So these are called S subshells, S orbitals. Then when you go to the second floor, notice that you have 2 rooms. One room holds 2 electrons, and then the other room holds 6 electrons. Now that's as far as you need to go. I'd like for you to know what an S orbital is and what a P orbital. So an S holds 2 and a P holds 6. And then notice that each floor that you go to, it adds another room. And so you can see that the next room that's added is called a D subshell, and then the F subshell, which you don't need to worry about. So just understand, what does it mean when it holds 2 electrons, and what does it mean when it holds 6 electrons? Okay, and then the way that we fill up the hotel is we take an electron and we drop it into the hotel, and the electron always wants to go as low as possible. So it would rather go into the first energy level than the second energy level. And then if it's got its choice in rooms, it would rather have the S than the P. So if you just keep those 2 rules in your head, you can predict where the electrons are going to go. And then the next thing, though, is the outermost electrons. The outermost electrons in an atom are going to be called the valence electrons. They're very important because it's the valence electrons that take part in chemical reactions. The other electrons don't. The other electrons are buried. So the uppermost electrons in the apartment building, the uppermost electrons, those are the valence ones. The electrons that are underneath the valence electrons don't participate in chemical reactions. So it's important to know how many valence electrons an atom has. And all you got to remember is what column are you in. So if you're in column 1, so you see here, this is column 1, and so in column 1, it has 1 outer electron. So any element, so if we go back to the periodic table, you've got hydrogen here, and then all of these other atoms that are underneath it, so they have 1 outer electron because they're in column number 1. Okay, then you got column 2. So over here's column 2. It's got 2 outer electrons. And then over here, column 3, column 4, column 5, and then up to column 8. 8 is very important because that's the magic number. So the magic number in chemistry is going to be the number 8. If an atom can get 8 outer electrons, it's very happy. And so in chemical reactions, they beg, borrow, and steal electrons so that they get to this magic number of 8. And so, for example, salt. So salt is going to be NaCl. So you've got sodium, which is in column 1. So it's going to have 1 outer electron. So let's use a plus symbol for its outer electron. Chlorine is in column 7. So it's got 7 outer electrons. So let's say 1, 2, 3, 4, 5, 6, 7. So chlorine wants 8. So it says to sodium, can I have your electron? And sodium is in column 1, so it wants to get rid of 1 electron. So it would be happy. So that what happens is that chlorine just takes that electron. And so now this sodium, because it's missing an electron, is positively charged. This one, because it got the electron, is negatively charged. Opposites attract, so it holds it together as a salt crystal. So that is a chemical reaction. And then another thing is chemical substitution. So if we go back to the periodic table, since all of these elements here have the same outer electron configuration, that means they can substitute for each other. So that, for example, there's something that is called potassium chloride. So this is sodium chloride, but potassium can substitute for sodium because potassium is in that same column. That's right there. And that's very handy in chemical reactions. So that the ones that are in the same column, they react very similarly in chemical reactions. Okay, and then you should also know about a covalent bond, and you should also know about a metallic bond. This one here was an ionic bond because it made ions. It made a sodium ion and a chlorine ion that stuck together. So this would be an ionic reaction, and it makes an ionic bond. A covalent bond is where the electrons are shared. So the example that we used was water. Oxygen, and then hydrogen and hydrogen. Hydrogen's in column 1. Oxygen is in column 6. So oxygen wants 8, and it sees all of this, and it wants them all. But hydrogen this time says, oh no, you don't, because hydrogen wants 2. And so here's hydrogen, and it's going to take those 2 electrons, and then this hydrogen wants those 2 electrons. It's a tug of war. So they both want the same electrons. They're sharing them, so it's a covalent bond. And then the third kind of bond only happens in metals. And so this is where you have the sharing of trillions and trillions of electrons between the metal ions. And so that's going to be called a metallic bond. Okay, so let's take a look at this. How do atoms bond together? And so there was only 2 of these that you needed to know for the exam, and it's the 2 that's in the right-hand column. So notice that water is a polar molecule, that oxygen is a bully. Since oxygen is bigger, it's got more electrical attraction than the hydrogens do. So the electrons spend more time around the oxygen, which means this end of the molecule is negative. And then this end of the molecule, down here where the electrons aren't, is positive. So overall, it's neutral, but the charge is separated. It's polarized. So this explains why water sticks together to make a liquid, because the negative end of one molecule of water will be attracted to the positive end of another molecule. It also explains why water can dissolve things, because in that case there, you can see it's dissolving salt. Salt is NaCl, so the negative end of the oxygen would be attracted to the positive end of this molecule, and it pulls it out of the crystal. So salt dissolves in water. Okay, and then you should also know about viscosity, and don't worry about the surface tension, and don't worry about the capillary action. So let's just concentrate on the viscosity. This explains how different substances like water stick to each other. The more they stick to each other, the more viscous the liquid is going to be. This is going to be very important because when we talk about volcanoes, some lava is very viscous and other lava is runny. And so this will explain how volcanoes explode. So just know what the definition of viscosity is. All right, let's take a break. When we come back, we're going to talk about minerals.